Okay. This is for Nevada, as I mentioned, and as Kim mentioned, rather, and I'll talk a little bit about the data compilation first, and then the supplemental funding for the drilling results. Of the data sets that we compiled, we're this lists the number of data sets that are available. Like, for instance, geology, geochemistry, geophysics, that's all kinds of different, all kinds of different things. I guess I can't click with my mouse. That I'll show a couple of examples. One of the derivative products of this work has been the one in geology, which as of a couple months ago had the greatest contribution of any of the states in the country, and I think the second greatest number of contributions in the world. So it's did a fair amount of work with converting a lot of these maps and attributing and whatnot. Here's a couple of example data sets, a couple of them that were the largest as far as time commitment. For the well logs, we used the Arizona well header template, and we scanned over 2,000 fanfold logs from over 850 geothermal wells, and of course filled in their template with the various well data, depth, temperature, date of drilling, etc. And we've posted all of these logs along with any associated documents such as permits, notices, any like page-size maps, miscellaneous reports that are associated with it. So if you do a search on their using their well header template, all of these documents are categorized by API number in a directory, and you can get these multiple logs, multiple reports in the same place. The aqueous geochemistry has over 40,000 records for Nevada from a variety of different sources. One of the big time sinks for this was to check and revise location data for these records. This has major and trace elements, gas, isotope data. Again, this was using one of Arizona developed templates. We've also, of course, calculated charge balances and have geothermometer calculations associated with all of these records, which of course are not all complete, as anybody who does databases knows. As part of our purview, we developed and maintained the Western Regional Hub. So that involved assisting other states with posting or their services, or creating map services and that sort of thing, as well as being a site for replication of data, so that it helps the system stay up if one or the other hub goes down. Derivative products that were involved include interactive maps and map services. And this is an example of one of the interactive maps, which we actually are updating right now. This particular one contains 80 data layers, and here's the website where it's located. Here I've clicked on some of the layers. This shows, again, some of the layers with a geothermal favorability map in the background.
Sounds like questions.
Did I go away? No? This is the same view, but it took the geothermal favorability map away and shows areas that are designated as geothermal areas that are named here. Desert Peak Brady's, for instance. We have heat flow wells, primarily from the SMU database, hot springs, various temperature, chemistry associated with them, power lines. Again, this is just, you know, some of the data that could be viewed interactively online from this particular interactive map. And I just wanted to comment about some of the tools that were developed by Gary Johnson. Again, this is the same area, and I just did a regular info query, and it just shows information that's associated with this particular power plant. But he also developed some tools that allow for querying, such as show all wells that are greater than 100 C, doing various searches, and the extract capability, which I've found extremely useful. You can go into this interactive map and click on whatever data sets that you want. As I say, there's 80 of them in there right now. And draw a box around the area that you're interested in, and it will download a file that will directly import into ArcMap, including all of the shape files with their attributes associated with it. So it's a very fast way to get data downloaded for your particular area of interest, and I've used it, and it's great. Industry use of data products. Some of the information I have here, it's basically anecdotal from personal knowledge. I kind of threw this together this morning. Here's some of the companies that I'm aware of that have been using the NGDS data for various things. Geochemistry is one of the big ones that's used, but also we have shallow temperature survey data out there, for instance. This lists some of the companies. And here's some of the sites that have been looked at in the last 2 or 3 years by the various companies. So it's throughout Nevada. They're primarily looking for electric grade resources, but some of these are also for direct use. Like, for instance, the Grand Sierra property was looking at it for space heating. That's a fairly large hotel here in Reno. And it's part of the supplemental work. We evaluated what was available in the geochemical database, and there was a fairly big gap in data in eastern Nevada. Most of the work has been done in western and northwestern Nevada. So we've had a sampling crew go out there and visited 42 different sites and sampled 16 of them. This map shows the various sites that were sampled in eastern Nevada with temperature. You see the highest temperatures, which are above 40 degrees C in the springs, are red. The blue dots were visited, temperature measured, if there was actually flow. Some of these, or none of those blue dots were sampled, but they were for various reasons, either access or no current flow, or they were too cold. Also part of the supplemental work was drilling of gradient holes and collecting some associated data at those sites. This map shows several sites in Nevada that were considered for more detailed studies, and the ones in blue were discarded for one reason or another from further consideration, often due to land access issues, or between the time we were looking at them and the time we were ready to collect data, a company leased the property, and we were trying to avoid looking at properties that would benefit a specific company. So what we're looking at here is the red triangles. We collected water chemistry from several springs within each area, and also collected shallow temperature surveys. And the 2 stars are where we drilled the temperature gradient wells. No chemistry were collected from those sites, as there were no hot springs or wells available in those areas. This one shows the Reno Airport area, which was selected for drilling one of the gradient wells. And here's the reasoning why. There's a well-known geothermal system called the Moana system that has been used in Warren and Manzanita estates for many years for space heating of domestic buildings. The Peppermill Casino right here is currently using the system 79 degrees C water to heat 2 million square feet of their towers. And then over the years, I've been contacted by the Grand Sierra Resort, Reno Airport, the Convention Center, and also Atlantis Casino, who are kind of on the margins of this, known area, to see if they had geothermal potential. And by and large, you can see within the circles that we have for those 3 areas, there's a big data gap. So this project gave us the opportunity to go in and try to fill in some information, because it was basically impossible to tell, for the airport, for instance, is there any geothermal potential there or not? And as I say, this allowed us the opportunity to look. Unfortunately, it was not hot. So we went in and we drilled a 1,000-foot gradient well at the airport, pretty much right in this location here, and did several temperature surveys. This first one was collected right after a day after the well was completed, so it's not equilibrated. And you can see, similar to what's been shown by Will earlier, it cooled off during the year as the surface temperature cooled at the surface. And the gradients I have here are from about 300 feet to total depth, so basically eliminating all of this surface variation resulting from excuse me, temperature variations through season. And looking at this, it's about a 56 degrees C per kilometer gradient. But that would put the depth to this 79 degrees C resource, which is what is actually being used currently by the nearby Peppermill Casino, put it at 4,000 feet. So that's not really economic at this point for this site. The other site was much more promising, the Emerson Pass. That was the star further north in the Nevada state map I showed earlier. It has a zone of tufa mounds. We did some shallow temperature surveys, and there's an area here that had high shallow temperatures. The purple dots are shallow gradient wells drilled by the Pyramid Lake Paiute tribe that they made available to us for measuring some gradients in. And the EG6 here is the well we put in for the 1,000-foot gradient well. This shows the temperature profiles from the four shallow wells that were drilled by the Pyramid Lake Paiute tribe. And interestingly, two of them, EG2 and 1, show what's known as isothermal temperature. And this one's plotted versus depth. This one is plotted versus elevation. And what we're looking at here, this temperature is just at boiling for this elevation. So we're looking at about a 50-foot zone of boiling at the same depth at these two locations. So that was an interesting result from that. This is the result of several temperature surveys collected from the 1,000-foot well we drilled with this project. The first one you can see wasn't yet equilibrated. It was only 5 days after completion of the well, but the others tracked pretty much right on top of each other. And what this one showed was a hydrothermal outflow plume that was about 500 feet thick at 117 degrees C. And while we were drilling this well, again, that log was from this location here, so we're seeing some sort of outflow going this way. And these two wells are the ones that showed boiling. While we were drilling this, I noticed that there was a zone of dead vegetation over here, and that's what's mapped out here. And so we thought we'd take a closer look. And what we did was a shallow, or a CO2 survey. This map again shows the outline of the dead zone. The blue are faults, and the dots here are sample locations for carbon dioxide flux. And this red line here shows an area of maximum flux as detected by the survey. And you can see it does not coincide with the mapped faults of the area. And this shows a cross-section from west to east across this transect with the different CO2 measurements showing the flux in CO2 in green, and then this blue line shows the maximum concentration of CO2 measured. Again, this is the zone of dead vegetation. And what was pretty obvious was the mapped faults, or the area around the mapped faults, do not show an anomaly, which would be suggestive that they may be barriers to flow, and or they're maybe mapped offset slightly from their actual location, because you see the biggest maximum is east of where the mapped faults are located. So looking at this in a much larger view, what we're looking at here, this yellow is the area where the wells were drilled. This red line here, that is the mapped out area of the dead zone, so you can see this is a much larger area. But we did the shallow temperature surveys over this larger area. Here's the tufa mounds. And what we're seeing is an outflow plume going south in the valley. Right here you can see the topographic contours It's going underneath the alluvial fan, so we may be actually missing some higher temperatures in here just because they're masked by the overburden. So these are showing temperatures at only 2 meters. So the pink in this area are 21 to 60, up to 60 degrees C were measured in this area along that fault zone that we were looking at in a previous slide. So this, we're looking at a steam heated fault controlled upwelling zone, an large outflow zone. We're seeing another upwelling zone here. So this particular area, once we look at the temperature distribution, looks like about a heat loss of, it's fairly small, but 30 megawatts thermal. However, we have fairly high temperatures at shallow depths that could very well be used for a variety of direct use applications. So as far as the main data collection activity, we have hundreds of data sets that are searchable through metadata records and also available through the Nevada Bureau of Mines and Geology website. There's hundreds of thousands, if not millions, I didn't count them, of individual records, dozens of data fields per record. We collected new data in eastern Nevada. They're generally lower temperature. Geothermometers don't indicate temperatures significantly above discharge. So they primarily be useful for direct use applications. We located and studied reasonably well one new prospect at Emerson Pass. During the course of this project, we've produced 26 publications, over 20 presentations, and this year at GRC I'll be talking about the results of the supplemental funding at Emerson Pass, also the CO2 surveys, and the Reno-Tahoe Airport. And as I mentioned, in all of these studies, there's multiple data sets such as shallow temperature, chemistry, and in the 2 cases, the gradient wells. Now, as far as the data management that a lot of people have been mentioning, we had started some of this prior to the initiation of the project. One of the things that allowed us to do was upgrade the technology for online maps. Gary Johnson's on the line if anybody has questions related to that, but basically a lot of the mapping features were upgraded through time as a result of availability of funding through this project. Thanks.
Great. Thank you, Lisa, and thanks for all the efforts that you've put in, especially over the last couple of years on this. I do want to go ahead and open it up for one question right now before we move on to Clark in Oregon. Question for Lisa or Gary? I think we're the first one.
Okay, Ricky, one quick question, Lisa. The shallow data, all the AMAX and Phillips and all that exploration data, is that best found through the SMU's website, or have you got it on your website?
Most of that's best found through SMU because anything in addition, we were not able to get a lot of this proprietary data that wasn't already available. That's one thing I didn't comment on, but the industry certainly hasn't been, in most cases, forthcoming with providing these historical data. So there's actually a lot more information out there, but it's in company files.
Okay. I may just then add the DOE report database for the whole of the department, I think, where sometimes companies like Geothermics have received DOE geothermal funding and lodged reports. There could be stuff that's still hidden in there but is public.
Yeah, like for instance, that Geothermics peer report that was done, I don't know, quite a few years ago, maybe 10 years ago now. That information, yes, is available, and yeah, and I actually contacted them about updating that, and they were, you know, it's the same story. The new data is proprietary.